Okay, so like I said in the last video, I'm going to be talking about vectors in this one. So as you saw in the last video, I just basically did an intro and basically it was almost like a syllabus video. I just talked about what I'm going to be talking about in the next this whole series in general. So anyway, so really in the last video we just talked about the sum of the forces equals mass times the acceleration. So, or really the sum of the force vectors, a vector, that's what a vector is, equals mass times acceleration vector. So, yeah, so really in the end, if you don't get vectors, you're just, I'm going to be straight up with you, you're not going to pass this class, okay? So I'm going to do my best to get you all set up with vectors, but this is the whole course. We'll be dealing with vectors the whole time, so if you don't get it now, you'll eventually get it, so don't be too worried. So I have confidence in you. Don't worry. But yeah, so let me just erase that real quick. So really, in this video, we're just gonna be talking about any vector, just vectors in general. So really, this is gonna be basically two parts to this video. Well, it's gonna be one whole video, but then the first part of this video, I'm gonna be talking about just how you can break up vectors into components. So there's the triangle method of breaking up a vector into components, and there's the rectangular method. Essentially, you get the same results, but it just looks slightly different. So yeah. So anyway, so what is a vector in the end? So really, it's just a vector has components, like I said, but it has basically in the end just a direction, which can be just like an angle, which I'll show in a later video, and then also just the magnitude. Which is just the length of the vector. So yeah. So anyway, so the triangle method is going to be really like if let's say we just have a -3, 5 vector. So this is going to be completely in 2D. You can extend this. Just a vector can be to the nth degree. But we're not going to be focused on those right now. So just 2D vectors right now, and we'll eventually get to 3D vectors, 4D vectors. Don't worry about those. 40 and on, don't worry. That's more about linear algebra and stuff. But anyways, with this vector, really in the end, we have an x component, and then we have a y component. So really we're just going to have basically our vector is just going to be an arrow in the end. So arrow, like it's going to have a tail and a head. So the tail part is going to start at the origin, and it's going to go all the way to right here. So let me draw that a little bit better. Start right here and go down. I don't think that was much better, but oh well. So anyways, with the triangle method, you have basically this vector right here. And then, so if you go over 3 and then go up 5, then you're going to get this -3, 5 vector. So really, if you add the vectors -3, 0, so really this is just going to be -3, 0 plus 0, 5. So really this is one component and this is another component, So yeah, so this is the -3 one, so we could just go in the -3 direction, and then we have a +5 y vector. So yeah, so this is the triangle method, just because we created a triangle with this. So for the most part, I'm going to be dealing with this the whole time, So we're just going to have our angle, I'm just going to call it phi. Theta is up here, so don't want to duplicate things. But anyway, so you have your so you had -3 in the x direction, and then you had 5 in the y direction, and you get this vector. And you just get a triangle with this method, So, and the reason why I'm going to be using this one more often than not is just because if we have a triangle, we can use SOHCAHTOA, we can use sine or cosine to just basically denote these a little bit better, and it's just it's a little bit easier when you're doing the sum the force vectors, just in general. So usually it'll be like a sine and cosine, but I guess here and there you'll see tangent, But anyway, so now if we try and draw the rectangular method, we're going to have the same exact thing, except for I'm going to draw the components first. So really, so we get this, and then it's going to be like this. Here, let me draw that a little bit better. Okay, so really the reason why it's a rectangular method is just because you can just make these dotted lines and it's a rectangle now, you know. So yeah, you can use adjacent and an opposite still in the rectangular form. However, it's just not as straightforward, you know. So that's why I said I'm going to use this for the most part, just because you can literally see this is the adjacent side and this is literally the opposite side. You're using a triangle. This you're using a rectangle. Rectangles don't have opposite and adjacent sides, you know. I guess this is and this is the opposite side, and this are the adjacent side, but it's not a triangle still. So triangle trick, you know, like they're linked. Okay, so now that we've gone over how to break up vectors into components properly, I'm going to be going over how to add vectors together. So before I do that, I just want to talk about one thing about components. Yeah, so basically in the last part, I just showed we had the -3, 5 vector, you know, this vector right here, and we broke it up in components. And whenever you're going to be breaking stuff up into components, technically you can break up vectors into 90-degree components, but I don't know if they're still called components then. I wouldn't call them components then, but in general, they're always going to be 90 degrees from each other, you know. So you have your x component and your y component. X is 90 degrees from y, you know. As you can see, this is 90 degrees, but yeah. So always make sure you're breaking up your components in this class into 90-degree components. So not components that are really weird. So technically, I guess this almost could be components because you add these two and you get this. You know, you're basically decomposing that vector into two smaller vectors in the end. But yeah, so whenever you break up in components, do this. Don't do what I just said. Just make sure they're at 90 degrees. So make sure you do a x and y, and if it's necessary, z if you're doing 3D. So yeah. So now let's do vector addition. So really for this part, I'm going to be just making you do just a plus b equals c. So we're just going to find out what the c vector is when we just add these two vectors together. So yeah, so anyway, so sometimes you'll get like a 2 in front or like a 3 in front of this. Really, this is just the scalar associated with that vector. And all that you really do is just you multiply, like you would multiply this by 2 and this by 2. And then same thing for b, you know, you multiply this by 3 and multiply this by 3. So really you just multiply that scalar into each component that you have for that vector. So, but we're not going to be doing that. We're not going to do that. We're just going to do a plus b, and we're going to get c in the end. So we're not going to make it too complicated right now. So don't worry. Okay, so before I continue on with this, I just want to say one thing. So if we have just a subtraction of vectors, really in the end, this is just going to be a plus negative b. So just like, you know, 2 minus 2 is just the same thing as 2 plus a negative 2. You know, it's the same exact thing, and that just equals 0. So so the same thing happens right here, you know. It's going to be a plus the negative version of b. So what happens when you multiply a negative number by a negative scalar times by a vector? So a scalar just is a fancy word for numbers. So or just yeah, just a number. So I state that later on this video series, but yeah. So anyway, so for b it's going to be negative 2, 2. So let me just draw that vector. Okay. So so what happens when we multiply this by scale it by 2? Really, we're going to get this kind of vector in the end. So it's going to be negative 4, 4 vector. So what happens when we make it negative is that it goes in the negative direction. So it just goes opposite of where it's headed. So in 3D space it still works, and I guess 4D and on, it's linear algebra, so it still works later on. So but anyway, so really this is just b in the end. So yeah, so if it's negative, if you're subtracting vectors, literally wherever it's minus b, or like minus that vector is just going to be negative, and it's going to be the addition of those vectors. So yeah, so let me get rid of this real quick, and then we'll continue on. So yeah, so we have b right here, and then a is just 2 and 4. So we go over 2, and then we go up 4 for a. So really, this is going to be a in the end. So we have a in the end, and then we have b right here. So in order to get c, then we just have to add these two vectors, and really there's almost two different methods for this. Again, they're literally exactly the same, to be honest, in my opinion. But like it's like you have a triangle method, and then you also have a almost like a pseudo rectangular method. I call it a quadrilateral method, because it's not necessarily 90 degrees. But yeah, so really, when you're adding vectors, it's going to be tail to head plus tail to head, just like you had with components. If you add the components, that's literally, to get the original vector, that's literally just adding vectors in the end, So, so really, if we had this, we're going to go over 2 and then up 2. So really, this is going to be that. So really, C is going to be, that's not good. C is going to be this guy in the end. So that's C in the end. And yeah, so this is the triangle method, and I'll point that out in a little bit. But yeah, so if we do the other side, is going to be, we have to go A from here. So really, we're going to go right 2 and then up 4. So really, we just go to the same spot, Terrible. Hopefully I get better at this. So, but yeah. So really, this is the triangle method. This is the quadrilateral method, in my opinion. So they both give you C in the end, so it doesn't really matter. You're not going to be using opposite over adjacent for this, so don't worry about that. There's no trig involved with this type of triangle, so it's not too intensive, in my opinion. So, but yeah, so when you're adding vectors, it's just tail to head, and then you have your vector in the end. So, so how you do this in the end is, how you add them mathematically is really cx, or basically, c is just going to be cx comma cy, since we're just dealing with 2D. So if you want to find out what cx is, it's just going to be ax plus bx. And so what is ax? It's 2. What's bx? It's negative 2. So it's going to be 2 minus 2, so that gives you 0. Which makes sense with this drawing, just because there's no x component with c. C is completely vertical. Completely vertical. There's no, it doesn't go right to, it goes up. In the end, I think that's 6. So yeah, I just can't read past those numbers. But yeah, so if we do cy, we should just get 6 in the end, So so now it's just going to be ay plus by, and in the end, then we're going to get 4 plus 2, which is just 6. So c in the end is just going to equal 0, 6. So which is just this vector in the end. So yeah, so that's just basically how you add vectors in the end. Technically, it's 2 methods, but really it's just the same method, in my opinion. Method 1 and method 1.5. It's not much different. So the other one, you have your triangle method and your rectangular method. They just look a little bit different, but it's got a little bit more meaning to it, in my opinion, than triangle and rectangle with triangle and quadrilateral, in my opinion, right here. So, but yeah, so really, yeah, that's just how you add vectors in the end.